welcome to Bridging the Gap between Snowflake and Esri. Today, we are joined by both Sinai and Dan as our presenters. I will pass things over to Sinai to introduce herself.
Sure. Hi, everyone. I'm Sinai. I'm a customer solutions specialist. I've been with SAFE for about 5 years now. Yeah, happy to be here. Pass it on to Dan.
I'm also a customer solutions specialist, so kind of do the same things as Sinai. We focus on helping our customers get the most out of our products. So we're excited to talk to you today about Snowflake and Esri and how we can help with that.
Mm-hmm.
Amazing. And our hero behind the scenes, Steve, is joining us on questions today. Steve, would you like to introduce yourself?
Yeah, good day, everyone. Been with SAFE for close to 15 years now. I'm on the customers support team, and I work predominantly on the FME flow side and with all sorts of databases, including Snowflake and geodatabases.
Awesome. Yeah, so please do, as we go through here, if you have any questions about today's content, drop those in the questions tab, which you'll see on the bottom right there, and Steve will be on standby. And then we'll also have some time at the end for live questions. Keep letting us know where you're tuning in from in the chat there. And we also do have a couple polls coming up, so keep an eye out for those. If you have any audio or video issues during the webinar, just click that help button for 4 simple steps. And then lastly, share your emoji reactions with us during the webinar. Those really fuel us, give us energy as we go, and we love to see how everyone's reacting to the content as we move along. Awesome. Thanks, everyone. If you do wish to download the slides, there is a button on the top right of the PDF that you can click as well. Okay, at this point, I'm going to prompt our team here to turn off their webcams just to save on some bandwidth for the remainder. And I'll take us briefly through our agenda for today. So we're going to be kicking things off with an introduction to both today's topic and the importance of it, as well as the FME platform. From there, we'll be going into data migration and synchronization techniques, as well as visualizing Snowflake spatial data. And then the following section will be on handling documents and attachments. And then last but not least, integrating SQL with Snowflake and Esri. I know we do have 5 demos today, so stay tuned for those. I know everyone loves to see the behind the scenes and the workspaces, so lots of demo content today. And then we'll be wrapping up with our conclusion and resources and next steps to help you get started after today's webinar. And then last but not least, our Q&A session. Okay, so to kick us off here, we have a poll, and I will launch that now. We'd like to know, how do you currently integrate data between Snowflake and Esri? So that's just under the polls tab on the bottom right. I'll give everyone a moment. What's the team expecting to see here from the results?
Either custom scripts or other ETL tools.
Yeah, of course,
since they don't natively integrate.
Yeah. Okay, well, it looks like we have most results and a lot of opportunity for the audience to learn here today, because it looks like about 70% not currently integrating. So that's really good information to know and great opportunity for a lot of people.
Yes, it'll be a great webinar.
Yeah. Amazing. Okay. So from here, I will pass things over to Dan for our introduction. Thanks, everyone.
Great. Thanks, Elizabeth. Yeah, so today we'll be showing you how to unlock seamless integration between Snowflake and Esri using FME. We'll get things started with a flash demo. So this will just help those who aren't familiar with FME or those who are curious about FME, what it looks like, to get an idea of what it looks like, as well as what a simple ETL or data integration workflow might look like. So in our workspace, we'll start off by adding a reader. We'll be adding a file geodatabase reader. So for those who aren't familiar with FME, a reader is how you add your data or your data sets into your workspace. And this is where we're building out our ETL workflow. So in our data set, we have postal addresses and postcode boundaries. And we want to find out the number of addresses that are within each of the postcode boundaries. So first, we can run our readers just to see what our data looks like. So with feature caching enabled, we can view our data straight in our workspace. It's a great tool for debugging or just seeing what your data sets look like as you build out your workspaces in FME. So we have our two data sets here. We have our postcode boundaries and our postal addresses. We'll connect those up to our point on area overlayer. This is how we're going to calculate those overlaps. So we'll assign it a new name, which is address count, and then we'll run that. And we can take a look at our areas, and you can see here we have the address count field now, so we know how many addresses lie within each of those boundaries. We'll add another transformer, which is our reprojector. So we want to make sure that our coordinate system is set to our UTM coordinate system. So we'll be connecting that up, and we can search for our local UTM coordinate system for the Vancouver area, which is where this data set is based. So these transformers we're using in this workspace, these are our tools that allow us to manipulate our data, to calculate new values, or perform spatial operations. Our writer then allows us to output our data to our destination. In this case, we're going to be writing to Snowflake, and we've selected a saved database connection there. So that allows us to easily connect to our database in Snowflake, and we can read and write from that. We'll provide our table name, and we can write to existing or create new tables, and we can perform all sorts of functions such as truncates, drop and creates, all sorts of things. You can see we can also set the geometry or spatial column name, and we'll give that a run. So that's finished running successfully. As you can see there, translation was successful and all 21 features were written. We'll go into Snowflake just to check that this data set was written as expected. And we'll scroll down here. And you can see we've written out that table. So very simple integration workflow where we're just integrating between Esri and Snowflake. But as you can see, it's pretty easy just to drop down a reader, a couple transformers, and a writer and have a workspace ready in a matter of a couple of minutes. So the idea here is just to give you a bit of an overview of how you could build out those workspaces in FME if you're not familiar with that. So why does Esri and Snowflake integration matter? Well, organizations are increasingly needing to combine geospatial intelligence with enterprise scale data warehousing, and performance, scalability, analytics, and breaking down data silos are all challenges that organizations need to solve. Snowflake and Esri bring complementary strengths to the table, so neither one is necessarily competing with the other. They just have their own strengths that we might want to take advantage of. So in a lot of cases, you might have organizations who have both Snowflake and Esri deployments, and they're not considering of replacing one with the other. They want to have them working in harmony. So we have another poll here. Which FME capability is most valuable for you with Snowflake and Esri? A few different choices here.
Yeah, and I think I made it, so feel free to select your top 1 to 2. Under the polls tab there. Okay. Looks like we have most results in now.
Yeah, looks like data preparation and transformation is probably one of the biggest, which is great. That's what we're going to be looking at today, as well as data movement and integration beyond the GIS and cloud is also another pretty popular one. Awesome, that's great to see. So a bit of an overview of the strengths on each side. I think we all know that Snowflake is great for scalability and storage. They really make that easy. You don't have to go through the deployment setups. You can just choose your warehouse size and spin things up, and it's great for storing bulk loads of data. So you can work with large amounts of data and perform analytics on that data without running into any issues or slowdowns. Esri's strengths lie more in the geospatial tools and the visualization capabilities, especially around cartographic mapping. Esri has huge strengths around that. I'm sure we're all familiar with that side of things. And Esri's products also provide data context. So you get things like specific formats, schemas, relationships, domains, attachments. We can work with all of those more niche things within Esri platforms. So we'll be looking at how we can kind of synchronize the two here. Yeah, so FME is going to help us bridge that gap between these two systems, which typically can't talk to each other natively out of the box. And we'll be showing you a few different workflows today. So this is the FME Enterprise Integration Platform for those who aren't familiar. In that flash demo, we were taking a look at FME Form. That's our authoring environment where we build out our data integration workflows. FME Flow is our orchestration and automation environment where we can bring our FME Form workflows to life. So this is where we can manage those workflows and set them up on automations using things like schedules, webhooks, and lots more. We also have FME Flow Hosted, which is our SaaS deployment of FME Flow. And FME Realize is our augmented reality application, which allows you to view your data in the real world. We can work with over 500 data types in FME. So today we'll be focusing in on GIS as well as cloud and big data, but we can work with various other formats, and we're always expanding the formats and the data types that we can work with. So if you have any that you're interested in, please do let us know. And with FME, we can work with all data velocities, whether that's batch, event, or stream. We can deploy in all data locations, so you're not restricted to just the cloud or just on-prem. We can also deploy, in containers or on the edge. We support all data types, as I just mentioned, so from unstructured to structured data, spatial data, APIs, web apps, it's all possible with FME. And we're not restricting you to any AI technology. So we want you to choose the AI service that is best for you. So if you want to connect to OpenAI, Amazon Bedrock, or Gemini, that's all possible in FME through our AI connectors. In terms of Esri integrations, we can connect with ArcGIS feature services. So that's ArcGIS Online, Enterprise, Server. We can also connect with your file formats, such as geodatabases, shapefiles, and we can also work with SDE geodatabases. Yeah, so lots of different formats supported here. And this has kind of been our bread and butter since the beginning of FME. We also have the Esri ArcGIS connector package. So this allows you to manage documents, attachments, and all your resources in ArcGIS Online. There's also the attachment connector, and we have the branch version manager. So this is more for those management kind of high-level workflows as opposed to the data movement side of things. And on the Snowflake side, we have the Snowflake Reader and Writer, like you just saw in that flash demo. We have bulk insert capabilities for large data loads, so we definitely recommend using that whenever you're writing large amounts of data into Snowflake. We can load, hundreds of thousands or millions of rows in a pretty fast amount of time. We encourage you to leverage Snowflake SQL statements. So what we like to say is let the database do the work, whether that's on your reader or your writer. You can specify SQL statements to run alongside your reads and writes. So we encourage you to do that to speed up your workflows and improve efficiency. And I know authentication is kind of top of mind as Snowflake is moving away from basic authentication. And we do support OAuth, browser-based SSO, and key pair authentication as well. So we'll be talking about data integration, data migration, and synchronization for a little bit here. This is kind of our first standard use case that most users might approach. And why does this matter? So again, as we mentioned before, organizations are shifting to cloud platforms. They might want to do data movement from their Esri platforms over to Snowflake. But this migration isn't just a one-time job. It's an ongoing process that is essential for keeping data up to date in both platforms. And as we mentioned earlier, both Esri and Snowflake play vital roles in our organizations. So we're not just limited to one platform. And really the challenge here is that bulk transfers between Esri and Snowflake aren't really straightforward. Esri datasets often have geometry, there's schema quirks, things like relationships and domains, and Snowflake excels at raw scale, but it can't natively import data from Esri formats. So organizations need a way to move data reliably and repeatedly, and we'll be showing you how to do so with FME. So we'll take a look at our demo for data migration and synchronization here. So we're reading in data from an SDE dataset. We're also specifying a where clause on our reader. This just allows us to filter out those records that we don't need before even having to read them. So overall, improving the efficiency of our workflow. We then are doing some data cleanup. So we have, an attribute remover, bulk attribute renamer to set our case type. And we're also filtering our geometry just for area. And so polygon geometry only. And we'll be using a change detector in this workflow to synchronize our data sets. So in a workspace that we want to have running repeatedly on a schedule, we might have this running weekly or nightly to synchronize our Esri and our Snowflake data sets. We can use a change detector where we can provide our key attributes, set our attributes that we want to check for changes on, and we can also check for changes in geometry as well. And we have options for lenient matching and setting tolerances there. So we'll run our change detector, and this is going to be reading in our current Snowflake data set. And that is our original data set. And then our SDE data set is our revised data. And as a result, you can see we have around 47,000 new records. This is our table name, and we set our operation to FME DB operation. I'll just pause it here for a second. So FME DB operation, this attribute is coming from our change detector. For those who haven't used it before, it just tells you whether or not you need to insert, update, or delete your records. So the advantage here is we can just have a single writer on our workspace and connect up all our change detector output ports to it, and it'll perform the operation as indicated by your row. So we'll click run on this, and we also have bulk mode enabled. So what's happening in bulk mode is that we're loading data into a CSV file, I believe, and we're just using a copy into statement there, which you can see in our translation log. So that's allowing us to do huge data movements in a relatively small amount of time. So just for 40,000 records or so, took about 16 seconds. So it's a pretty efficient movement there of our data. So some of the outcomes here, we definitely recommend using the change detector to easily perform CDC within FME. There's various other methods for CDC, so if you're interested in that, definitely check out another one of our webinars on change detection that we had a couple months ago. We recommend using bulk mode if possible. I believe this is enabled by default, so in most cases you should be using it. And deploy FME close to the data. If your data lives in the cloud or lives on-prem, we recommend deploying FME as close as possible so that your processing is as close to the data. You don't run into data latency issues, and you can have the highest performance possible. So the next step here could be to automate with FME flow using schedules or webhook triggers. I know Esri has support for detecting changes on feature services with webhooks, so that's another possibility there for synchronizing your changes between Esri and Snowflake. And now we'll talk a little bit about visualizing Snowflake spatial data. So this is going to be kind of playing off that last change detection capture data migration demo. And the challenge here is that Snowflake, it can store massive spatial data sets, but overall, it doesn't have the strongest cartography tools. It's just not built as a cartography tool, whereas Esri has, rich visualization tools such as ArcGIS Online dashboards that we can use to leverage to display our data. So in this workflow, we'll be looking at how FME can migrate data from Snowflake to Esri in the correct schema. We want to optimize our queries, so we're only sending the data that's needed for visualization. And we can automate our updates with an FME flow schedule to keep our dashboards alive. So the goal here is to allow organizations to visualize their Snowflake spatial data. And the reason we're doing this is that organizations might be receiving spatial data from various different sources. They might not necessarily have all their data in Esri, so they might aggregate all their data to their data warehouse, which is Snowflake in this case, and then they want to take some of that data and visualize it. So stakeholders can get a quick view of their data and perform analysis. So we're going to do so by connecting Snowflake to Esri and query for only the required data. And the result is that businesses can now observe their spatial data and analytics in a live dashboard. So we'll take a look through our demo for visualizing Snowflake spatial data. This is a relatively simple workspace where we're just reading in a data set of water gauges. So this is for water level heights in Austin, Texas. You can see we have a few records there that are either null or have a negative value. And we just want to map these to a value of 0, just so that these don't show up as extraneous values on our dashboard. So we're using an attribute manager for this process. And once we've cleaned up our data, we can write that out to Snowflake. And you can see we've also mapped our schema here between our attribute manager and our Snowflake writer. We can then publish this workspace up to our FME flow. We can publish connections if needed and any packages. So that would include our ArcGIS connector package. And then we'll publish it as a job submitter. And we can build out an automation that looks something like this. So we have an FME flow schedule trigger here. We can set it to repeat on interval. And we can set this down to run every 5 minutes or every 5 seconds so that we're keeping that data in our dashboard live. Since this is a flood monitoring kind of workflow here, we don't necessarily need to have our data set running every 5 minutes, since those changes in the water level are going to be coming in around closer to every five minutes or so. And once we've written that data up to Esri, specifically ArcGIS Online, we can then visualize this data in a dashboard that looks something like this. So underneath, this is just tapping into that same data that we just wrote to ArcGIS Online. But the advantage here is that Esri has pretty strong tools for creating things like a dynamic dashboard where you can get information about your data set. You can visualize that for easy, quick analysis, and you can set up additional information such as what the current water level is of the action stage or the flood stage. So again, the outcome here is pretty simple, but very powerful. We're able to take our data from Snowflake and visualize that in an ArcGIS Online dashboard. If you do have other dashboards or cartography tools you want to move your Snowflake data to visualize it, you can also do that. You're not limited to what we've shown here today, but it's just an example of how you could set up a workflow. And the key component here is that we also have a schedule running in the background that's constantly updating our data so that our dashboard is live and it doesn't have stale data there. So moving beyond tables, this is a question I got asked recently by users. How do I migrate documents from Esri to Snowflake? So we all know that Esri has very strong support for documents, images, attachments. So we'll be taking a look at how we can move our data from this unstructured data from ArcGIS to Snowflake. Because out of the box, Snowflake doesn't necessarily have support for attachments, but we can use things like Stages to store our documents and use a reference ID on our table to link it to those documents. So for example, field inspections might result in photos getting collected in the field, and engineering and planning documents might be stored along spatial records. So when we move our data over to Snowflake, we don't want to lose these documents or these attachments. We still want to have them available if needed. The main component here is the ArcGIS attachment connector. This allows us to easily manage attachments, and we can perform actions like add, delete, download, list, and update. And we'll also be using Snowflake Stages. So this is where we'll be storing our documents and our attachments in Snowflake. And all this work is done using a SQL executor to load our documents from ArcGIS into Snowflake. So starting off in ArcGIS Online, we have our tree inventory dataset here, just keeping it simple with a relatively small dataset, so around 10 records. But each of these records has an attachment associated with it. So each record is going to have an image that relates to the tree itself. So in our workspace, our first step here is to read our existing data. So this is that same data set you just saw in ArcGIS Online. The reason we need to read in this data set is because, first we want to write that data over to Snowflake, but we also need those object IDs to feed into our ArcGIS attachment connector. So we'll write over to Snowflake first, and then we'll read in those attachments. We'll go into Snowflake and take a look at the table quickly. So after we've written our data, you can see we also have an attachment ID field. So we're going to fill this out later once we migrate our documents over to Snowflake. This first attachment connector is listing all our attachments. So it's going to do this row by row for each object ID that we're providing it. And we're using our REST URL here as our feature service URL. And then once we've run that, you can see we have attachment IDs. The next step is to then download the attachments themselves. So we've set it to the download action. We're again using the same feature URL. We're providing that attachment ID as the attribute. And we also want to download our our files as attributes. And I'll pause this for a second. The reason we want to download our files as attributes is because it allows us to control the name that we're outputting our data to. So if we were to just download with the attachment connector, we would get the same name as the attachments themselves are named in ArcGIS Online. But we want to have control over the file name because we need to provide it with an ID so that we can connect it and provide that relationship between our Snowflake table and the documents in the Snowflake stage. So that's what we're going to be doing in our attribute creator. We're setting the output file path, and we're setting the file name to have that tree ID and the attachment name. And then we're using a string replacer. We just need to make sure that all our backslashes are replaced with forward slashes. And that's just a requirement of the Snowflake SQL statement for loading data into the Snowflake stage. And here we're using an attribute file writer. So this allows us to take that binary data and write it out to files in our local directory. The last step here is to use a SQL statement to upload our data to the stage. So we have a stage called attachment stage in Snowflake, and it's just the matter of a simple put statement to load that data into the Snowflake stage. So we'll run this. And you can see it's executing those SQL statements, and it's loading those documents up into our stage. So let's go take a look at our stage. We'll scroll down, open up our stages. You can see we have our attachment stage here. And let's refresh the page. And now we have each of our attachments in there. And you can see they're also, they also have the prefix tree ID as well, so we can relate them to each record in our table. So that's what we're doing with this last attribute creator here. We're creating that essentially the name of the attachment and where it exists. So it's in the attachment stage with the file name and the tree ID prefix. And we're going to be updating our table, and we're just updating that attachment ID field. So let's click run on this. That's going to update our tree IDs, or sorry, the attachment IDs. And then we'll go take a look in Snowflake in a second, and just to make sure that those IDs were written there as well. So let's refresh our table, and you can see those attachment IDs were updated. Awesome. So yeah, that's just a simple example of how you can migrate documents from Esri to Snowflake. A bit of a recap here is that the ArcGIS attachment connector is a very powerful tool. It gives you a lot of control and oversight of what's happening when you're working with those attachments. So highly recommend using that. The SQL executor makes it easy to leverage SQL queries. You saw I just had a simple SQL statement, and for each record or attachment that's coming in, I can execute a SQL statement to upload that to our stage. And the result is that we have attachments that are traceable, and as we've updated the Snowflake table with an attachment ID. And an optional transformer you could use here is the temp path name creator. This just creates a temporary folder that FME will clean up later. So when you are downloading those files and writing them to a local directory, you could first have a temp path name creator in your workspace. Use this as your temporary storage location on your local drive, and then FME will do all the cleanup afterwards. So once those records and attachments are up in Snowflake, everything will get cleaned up, and you don't have stragglers hanging around on your local drive. So at this point, I'll pass it over to Sinai.
Thanks, Dan. Okay, so as I'm sure you've noticed, lots of our demos so far have featured SQL here or there, So I'm going to talk a little bit about why SQL matters so much for these types of workflows. Snowflake is a database at its core. It's optimized to run queries, not just store data. So in most enterprise GIS workflows, we're going to be dealing with both geospatial tools as well as these large relational data sets. That means to get the most out of Snowflake, you really need to be using SQL to filter, shape, and join data before it even reaches Esri. So instead of just dumping everything into a GIS layer, we're going to pull only what's useful. This is aggregated, filtered, and already enriched. So SQL can show up at lots of different parts of an FME workflow, depending on what you're doing. It can be at the start, where you might use a where clause or general SQL statements to filter those rows before they even load. Or you could go mid-workflow. Something like the SQL executor will let you do joins and groupings and calculations based on the upstream results, just like Dan did in that last demo. You can also use tools like the new database courier to kick off a workflow based on a query. The key here is to really use SQL where it's going to make the biggest impact, so you move less data and keep things fast. So push down means filtering inside of Snowflake instead of pulling everything into FME. In a nutshell, instead of reading the full table, we tell Snowflake what to return before that data moves. And this is going to improve speed, reduce costs, especially with large or spatial data sets. It also supports spatial SQL, so we can push distance-based queries into the database. This is one of the easiest ways you're going to be able to speed things up and reduce load on your workflow, as well as use much less sort of temporary data when you're running workflows in FME. The SQL executor deserves a special shout out because it's going to be especially useful when you want to join or summarize data after some logic has already been run. So we can pass these dynamic inputs into the query, things like a filtered list of IDs or a bit of geometry and well-known text. And this way, Snowflake only returns relevant summary or match, not the full source table. And although not on this slide, the feature reader can do this as well to some extent. We can use the SQL to run before or after, as well as where statements directly on the reader for Snowflake. And you can even make complex data analysis and transformations more lightweight through SQL. And H3 is an example of that. H3 is a spatial indexing system that breaks the world into hexagonal cells at different resolutions. And Snowflake has native H3 functions, which means that we can do the binning right at the database level. This is useful when you have thousands or millions of points. H3 is going to help you group those and definitely reduce visual clutter in the end results. So instead of exporting raw data into Esri and doing the binning there, we can run the aggregation where the data already lives. This is going to be faster, reduce data movement, and scale a lot better with large data sets. The results will be ready to visualize in Esri as these hex polygons with all the values attached. So you use Snowflake's H3 when scalability and efficiency are going to be a priority. So especially when you're working with a cloud stored spatial data set. But on the other hand, Esri can also do hex binning through their analysis tools. And this could be a better choice if you're mostly focused on that cartographic output. Most of your data is in Esri, and you're not processing this very large volume of data that lives in Snowflake Cloud. So in the case of big data, let Snowflake do the heavy lifting using SQL and let Esri focus on that presentation part. So this demo is going to show how to run spatial analysis when your big data sets live in Snowflake and your spatial layers come from Esri. And we're going to heavily utilize SQL here. We have customer data in Snowflake and stored locations from ArcGIS Online. The customer data contains only addresses as well as transaction data, while the store data are just simply Esri points. With FME, we're going to build catchment areas around each store, pass those polygons into Snowflake, and run a spatial join across against those customer addresses. This is going to let us filter and group customers by catchment area directly inside of Snowflake without pulling those entire tables into Esri or FME. The result's going to be a really clean and focused data set that's ready to map or analyze. Okay. So we're going to start by looking at our data sets. Here we are in ArcGIS Online. We've got a couple of store locations stored as points. That's all there is here, no attributes, just a couple of point datas, 2 stores in the Los Angeles area. We also have some data in Snowflake. Here's our customer table. There's a loyalty score as well as an address associated with the customer, as well as some transaction data, so spend history associated with each customer. And this data here could be for the entire country, depending on the store. This could be a franchise, and maybe there's hundreds of locations in each state. So we need a way to bring these systems together so that we can analyze them at one without necessarily pulling in all of this customer data. We're just interested in that in the LA area. So we start by reading in those 2 points from ArcGIS Online. Here's our 2 stores as point data. And we can create catchment zones using the buffer tool in the workspace. So these buffers are what we're going to use to run a query on our Snowflake database. So to do that, we can start by using the feature reader. And we're going to connect to our Snowflake database and read in our customer table. And here we're going to use a where clause. And you can see we're passing in that buffer polygon with some spatial SQL. In this case, it's the stdwithin command. And this is only going to return the customers that are inside of those buffers. So only the customers around those stores. Next, we want to get some more information about these customers. So we're going to use the SQL executor to run another SQL statement, this time on the transactions table. And this simple select statement will pull all of the spend data and purchase history for every customer that we've pulled out from our catchment zones. So this is going to be a much richer profile of our customers for each store. And then we want to pull everything together. So we're going to use a feature joiner just to add that aggregated customer data back to our spatial features before publishing. Finally, we want to visualize these results. So we can publish this to ArcGIS Online, and the result will be a Snowflake enriched data set on a web map. So here you can see we have all of our customer points aggregated with spend attributes. So we started off with just a couple of simple store locations, and now we have a really complete picture of each store's customer base from that data stored in Snowflake. Obviously, this map in particular could probably benefit from a cartographer doing a better job, but you get the idea. This is the kind of thing that we can share easily with business analysts and other stakeholders that might be interested in this kind of information. We can do a lot more with SQL than joins and filtering them. So let's look at an H3 workflow. Here we're going to return to the buffers that we've made. This time we're going to dissolve it into one area. So here's our store zones. And just like before, we're going to use the geometry extractor transformer to turn that buffer into encoded text. In this case, well-known text. And this transformer is great to use before you're running any kind of SQL that's going to be spatial, because you can easily turn any kind of geometry into a string that you can use in a statement. So we will do just that. In this case, in our SQL executor again. So this statement is a little scarier than our last two, but that's just because I've combined a few different things into one statement. You could easily break this into a couple of different steps, but this is just one large statement doing a few things. So in this case, we are connecting to both our customer and transactions table in Snowflake, using our geometry to filter them out. And we are going to group our customers into hex cells. So we're calculating the totals for every cell. And then we'll get sort of a complete picture using hex mapping. And you can see we can even visualize that here in the data inspector. This is a really clean and generalized layer, and this kind of layer can scale to millions of rows and still convey a lot of information. And we can write these to ArcGIS Online as well. So this is H3 aggregation and ArcGIS Online. You'll often display something like this with graduated colors. Again, I'm sort of regretting my choice of color scale here. It's not the best looking, but you can see we have low spend to high spend customers and their distribution around those stores. So we can see all those hotspots of customer activity and spend. And it's a really efficient way to visualize patterns without overwhelming the map with individual points. So yeah, that's how you do it. And in this demo, every platform contributed, I think, its strengths. Snowflake handled that heavy lifting and processing. FME moved and transformed the data between systems. And Esri turned those results into a really clear visualization. So working together, they delivered insights faster and with a lot less effort. So the workflow combined all the filtering, spatial joins, enrichment, and aggregation in a single pipeline. SQL pushdown really kept things efficient. Spatial queries like SDD within identified the customers near each store, while the SQL executor added that transaction total and recency. So instead of exporting entire tables and storing those tables in FME's memory, we can just pull the results that we need. The customer records were enriched with extra fields for mapping and then grouped with H3 bins to simplify that visualization. And while doing this, I learned a couple things. One is that definitely utilize Snowflake's built-in AI, Cortex, for when you're generating or refining your SQL. This was something I found that sort of the generic AI tools could struggle with because it didn't have the context of the database. So definitely check that out if you're using Snowflake already. That'll speed run your SQL development, and you can easily transfer those statements that you build into FME using the tools that we looked at. So the end result of this workflow is focused insight, and it's achieved with really minimal data movement. Okay. So we started this webinar looking at the challenge of connecting Snowflake and Esri in a reliable and scalable way. FME fills that gap, handling spatial data, documents, and live synchronizations across both systems. Throughout the webinar, we saw how to automate those pipelines and make them repeatable. SQL played a key role, letting us filter and join and aggregate data inside of Snowflake before it ever even reaches Esri. This is going to reduce load, speed things up, and give us cleaner data to visualize. We certainly did not cover everything that you could do, even while listening to watching this webinar back or delivering this webinar. I'm thinking of demos that we could have done. I would have really liked to do something with maybe data virtualization, build an API with both Esri and Snowflake data, but that's for next time. I'm sure there'll be more Snowflake webinars on our horizon. But in the meantime, our takeaway message is that FME, Snowflake, and Esri each handled what they do best: data, compute, mapping, and the results should be scalable workflows that can turn raw data into usable insight. And with that, I'll pass it back to Elizabeth.
Amazing. Thanks, Sinai. Yeah, so just to take us through some wrap up before we have time to answer questions live, keep getting those in just as a reminder. Looks like we have a few, so that's great. But yeah, if you're newer to Safe Software, we have been in the data integration game for over 30 years. I think we're probably closer to like 32 plus now. And we've been working with over 25,000 organizations across the world. And with 140 plus global partners. Resources to help you get started. We do have a few highlighted here, and Dan and Sinai, if either of you have notes on these, but otherwise, yeah, definitely feel free to download the deck, and then you can click through these links directly to access those resources. All right. And then at SAFE as well, we are all about free resources. So you can gain even more learning on other topics as well by visiting our academy, academy.safe.com, where we have free instructor-led training. And our webinar program, we have lots of upcoming webinars on the horizon here. I think we just have a couple more being posted this week, actually, so stay tuned for those. And then we also have hundreds available on demand. So be sure to use that search bar depending on what you're looking to learn more about. Next steps to take. We'd love to chat anything data, info@safe.com. Feel free to reach out to us directly. And then if you are newer to FME, we also have a 90-minute free of charge accelerator course, and it's a great place to get started learning the basics. Claim your community badge. So if you're a member of our FME community, we do have a badge code as a thank you for joining us today. You can redeem this over in the community. I will post that in the chat now as well. And if you are newer to FME and the SAFE community, I highly encourage you to take a look. It has lots of forums and engagement with other users and experts alike there. Okay, with that, I will invite the team to join me back on the stage here with our webcams, and we can take a look through the questions tab together. I see we did get a few questions here at the end, but feel free, everyone. You can keep dropping questions as we go along. And then also, of course, if they come up after the webinar, we will leave things running a couple minutes past. All right.
We got some great questions in here. Steve, I see you're in the process of answering a question.
Yeah.
So I don't know if I want to answer that one. I was going to mention for that one, we can, let's bring it up live on the screen. Tobias was asking about change detection and whether the change detector is fast enough, which is a very valid question. You could also look at using an upsert operation if you only need to do inserts or updates. That would, remove the need for having a change detector in your workspace. So that could be a more efficient option as well.
Awesome. Okay. Yeah, and anything else? I think the comment about more examples of data virtualization came in right, Sinai, as you were saying that on air. So good to know that's of interest.
Yeah, it was sorely missed. Next time. Yeah, for the H3 binning, someone asked if we should send that data to Snowflake and WGS 84. That's what I did for my last workflow there with the H3 binning. I just used the reprojector to read that data in correctly from ArcGIS Online, and then before I wrote it back, reprojected it again. So just use the sort of coordinate system tools that we have. That's where transformers really enrich the workflow. It's a good question.
Thanks, Dan, for answering that question live. I was having technical difficulties trying to join the stage and turn camera on and microphone. The microphone wouldn't turn on, so I had to refresh my browser.
No worries.
Did you have anything else for that one, Steve?
No, I was a little distracted when you were answering, but my answer was just chatting about the CDC, like, change detector, having that there. And for millions of records, I'm not worried about FME pulling that data, but it's also the velocity that they need to update in Portal. If it's once an hour versus every minute, then we might have to look at different solutions. And that's where SQL Creator or Executor could maybe take advantage of last updated date in a Snowflake table and just pulling the data that it needs, as we saw from some great demos today, pulling that information into FME Flow to push to Portal. That would be the most efficient and reliable. The catch is ensuring that you always know when you last ran it to make sure you have a good date. Yeah. But yeah, it's good. Yeah, we're here for a few minutes for questions. So if anybody's got any others they want to put in there.
Yeah, it looks like so far you've gotten to them all.
Yeah, I guess, I've answered some of them, but it's this one here. The data virtualization one, I think Sinai, you can speak heavily to this, but it's relatively new. The use cases are growing, the examples are growing. And by all means, drop in and share a ticket with us, post a question in the community for additional information on that.
Mm-hmm.
I don't know if you got anything to add to that, Sinai.
Yeah, I mean, maybe just for anyone in the audience that hasn't seen data virtualization yet, the type of workflow that we might demonstrate using Esri and Snowflake would be to create an API that draws on data from both Snowflake and Esri. So maybe instead of my customer data output being a map, it would be an endpoint that other systems could send requests to and get the live data from both Snowflake and Esri in one API response. So that would be a great use case for integrating the two, as well as connecting to systems that maybe Snowflake or Esri don't play nice with, or you just need a more holistic and lightweight data delivery method. So keep your eyes out. I'm sure we'll have more data virtualization webinars coming up. Yeah.
Great. Thanks for adding more context to that for those new to DV or data virtualization.
Yeah, absolutely.
There's another question here on H3 binning, and my take on that, the default coordinate system for that's going to be WGS 84, latitude, longitude kind of stuff. I typically see it being used in that kind of map representation and larger scale of maps that you're looking at. Do you guys happen to know if there's any other customization you can do with H3? Like, can you make those polygons, state plane, coordinate system, something like that? I'm just kind of curious based on this question that wants to put data into Snowflake and do some H3 binning, but they're just wondering, does it have to be in WGS 84 and Snowflake to do that? And not to put you on the spot, because I'm guessing it needs to be in WGS 84.
I think so. I did the reprojection just because Esri's usually in Web Mercator, and then the geography stored in Snowflake is Esri's in 3857 and Snowflake's in 4326. So that's why usually I did the pre-projection first at the beginning of the workflow from Esri to Snowflake, and then once I had them both in the same coordinate system and did those spatial transformations, I reprojected it back, if that makes sense. But I didn't do too much experimentation otherwise. Dan, can you speak to some of the geometry part of it in Snowflake, or maybe we just need to take this question offline?
No, on the Snowflake side, I guess you'd want to use geometry or geography if you're using lat long. So
yeah,
WGS. But if you're using anything else, you'd want to use the geometry data type there. But FME does a pretty good job of doing that for you as well. So usually the coordinate systems aren't too much of a worry. Like if there's a requirement there, FME is going to handle it pretty well.
Yep, that's right. Awesome. All right. Well,
excellent. Well, I think that's everything. I know we are at the top of the hour. So just before we wrap up, it looks like our webinar survey is actually down at the moment. So if anyone wants to leave any comments on the webinar or feedback in the chat, we do read through those and it does help us improve our webinars. So really appreciate that in advance. But huge thank you in the meantime to Dan and Sinai for preparing today's content and presenting with us today. And then Steve as well for joining on questions. Really appreciate everyone's time. And big thank you to our whole audience. Thanks for joining today. We really appreciate your time and we hope you got a lot of value out of today's content. Thanks, everyone.
Thanks, everyone.
Yep.
Bye for now.